So, hello everybody. Welcome to panel 7. Panel 7 is on policies for a green recovery in the building sector. My name is Veit Bürger. I'm one of the two panel leaders. I'm working for the Öko Institute in Germany. I'm co-hosting this panel together with my colleague Jan Rosenow. Hello, Jan, who's one of the directors of the Regulatory Assistance Project. And this first slot today is on building performance and regulations. We have 4 interesting presentations, 4 interesting contributions. But before we start with that, one technical point. After each of the presentations, we have a couple of minutes for discussion or for raising questions to those who present. In order to raise the questions, I would really kindly ask you to use the question and answer tool in the Wova application. We will check that, we will collect the questions. And after each of the presentations, we will ask the presenters the questions, and in the end we might have another 10 minutes in order to have a brief discussions on the main topics. So we start with the first presentation. The first presentation is given by Stefan Thomas. Stefan is working for the Wuppertal Institute for Climate and Environment and Energy in Germany. He's director of the energy division there. And Thomas is speaking about next generation energy performance certificates and deep energy renovation. And Carol, I would like to ask you to start the recording, please. Carol, there seems to be no voice.
Hello, my name is Stefan Thomas. I'm the director of the Division Energy, Transport and Climate Policy at the Wuppertal Institute in Germany. Welcome to this presentation on the proposals and concepts from the QualDPC project. The presentation is entitled Next Generation Energy Performance Certificates and Deep Renovations, and here you see my co-authors. Let me please start with a short introduction to the QualDPC project. This is one of the 3 first in the cluster under Horizon 2020 on the next generation of energy performance certificates, or EPCs. We have 11 partners, of which 8 are implementing the project in 7 countries that participate. 2 are supporting the dialogue and dissemination, and the Wuppertal Institute is coordinating it. Our objectives are to enhance EPC schemes in 2 aspects. First, the quality and cross-EU convergence, including building assessment and the issuance and design of EPCs, the verification processes and the use of EPCs. And second, the link between EPCs and deep energy renovation. We do this in 4 phases. We first analyzed existing EPC schemes and good practice and shortcomings, and defined 7 priorities for improvement. We're currently in the phase of development and testing of concrete proposals and tools for the enhanced EPC schemes. We will then adapt the policies and proposals and tools to country needs, implement what is consensus and what is feasible for us, and develop a roadmap for further dialogue, and finally develop a sustainability strategy and conclusive policy recommendations for continued regional, national and transnational dialogue and transfer. So the main part of this presentation is about our draft concept and proposals for enhanced EPC schemes and the link to deep renovation. As I said, we have 7 development priorities which were developed first in the green paper. You see here the link. And this paper and this presentation are focusing on 4 of these 7 priorities which are related to deep energy renovation, which is A, improving the recommendations that are anyway already provided on the EPCs towards deep energy renovation, B, an online tool, C, deep renovation network platforms, and E, the high user friendliness of the EPC, whereas the other 3 are focusing on improved and regular EPC assessor training, and improving the use of EPCs in advertisements for real estate. In this green paper, we summarized the current situation in the partner countries for each of the 7 priorities, collected best practice examples, and then developed a proposal for each topic, which can be either a policy proposal or a tool or combining both. So let me know. These policy proposals are general proposals that could be adopted in any country in the EU. And some details may not be feasible in specific countries, or they may already exist. And so the next work package will develop the country-specific adaptations for the 7 countries included in our project. So let me start with priority A, the recommendations for renovation. We found that currently the recommendations that are provided on the EPCs are usually oriented towards minimum legal requirements and often only include low-cost measures. So if, for instance, the renovation of the facade or the roof is not deemed cost-effective by the assessor, he or she may not recommend this at all. So we think this is also maybe a misinterpretation of cost-effective or cost-optimal. And so our aim is to improve these recommendations so that they are compatible with deep energy renovation, and maybe the first step to building a deep renovation passport. There is no definition of deep renovation in the EU so far, and so we took as a guiding principle component efficiency levels that are derived from the national nearly zero energy building standards, which can be considered cost optimal. And so we developed a policy proposal with 15 areas of recommendations. You can find them in the paper. They are concerning, of course, the building shell, with often 2 levels, good and very good insulation properties. Then they are concerning the heating, ventilation and air conditioning systems. And finally, several special aspects. The second tool, second priority is a tool, an online tool for obtaining first recommendations on deep energy renovation. It's based on an existing home energy check tool from Greece. There are several similar tools in many countries, but not in all countries already existing. And the aim is to have a user-friendly user interface for building owners that allow them to understand which recommendations could be interesting for their building, so to discuss them with the EPC assessor. Or if they already have an EPC with maybe only a few recommendations, to get a second opinion of are these good or what else could be done. And based on some inputs for the building, this tool will allow to estimate the current energy efficiency, to select renovation options, or it will provide some recommendations to the user. and it will calculate an estimate for the energy efficiency and savings in case of renovation. But of course, this is only a first impression of what could be cost effective and could be done. So the tool will in any case recommend to obtain an energy audit to validate the energy demand and these recommendations. Then the tool will also be linked and included into what we call deep renovation network platforms, which is another tool, first of all. It is meant to be the concept of a one-stop shop, which is often discussed these days and tested for building owners willing to renovate, plus also a networking platform for the supply side actors in the renovation business, and for the joint communication and marketing, or also for training these supply side actors. It can take different forms, and it will help building owners to take the steps needed for renovation after they have an EPC, and best also based on the information in the EPC. So these deep renovation network platforms can either be an online platform or a local or regional physical hub, or also a combination of both. And they can provide information only, or they can guide and coach the building owner through the implementation, or they can even help organize the implementation itself, including the finance, for example. We've defined a basic version, which is an online information platform, whereas the extended versions can be all other types. And we've also prepared a policy proposal, which is for national governments to combine an online information platform at the national level, and financial and technical support for a network of local or regional physical hubs that also offer guidance or coaching, or even support with the actual implementation. The basic version, as I said, is mostly information on renovation actions, their benefits and costs, the link to the renovation calculation tool, and of course to energy performance certificates in explaining these. Also possibly with a building renovation passport, support with finding contractors or materials, information on financing opportunities, but also for the supply side actors, active marketing of deep renovation, and a networking platform for them for learning, exchange, and cooperation. The extended version could also include capacity building and training, or the step-by-step guidance and coaching for renovation projects, monitoring the implementation of renovation projects, operating a physical network hub and information center, maybe carrying out renovation projects on behalf of the building owners, maybe initiating and coordinating demonstration projects, or aggregation of building renovation projects. Then finally, the high user friendliness of the EPC, which concerns the EPC form or template itself. And our objective is to make these EPCs more useful as a first step towards deep energy renovation, but also for the buying and rental market of buildings, of course, which is the second objective of EPCs. We found that in many countries, the EPC forms implement the basic EPBD requirements, but asked ourselves, is this what building owners or potential buyers and tenants need? So we interviewed building owners and stakeholders and screened good practice, and identified and analyzed a long list of potential improvements, and then developed an enhanced general template for the EPC form and as a policy proposal, which has a standard design of 4 pages, room for adjustments according to national requirements, of course has the basic building data, but then not only the current energy classification, and data required by the EPBD, but also, as you see on the right column, a new classification and energy performance. And in addition, not only per square meter, but also for the whole building or dwelling in kilowatt hours per year, the savings that can be made, because this is more informative for users. Then we also have a scheme of classifying with a traffic light scheme the current efficiency of the building components and also of the recommendations, which of course should be then green and be based on our priority A, our improved recommendations. And the assessor can select a combination as the main option for which the savings will be given on page 1. And the fourth page also has a description of useful combinations and a stepwise implementation of the recommendations of the main option to be a first step towards a building renovation passport, and a link in the future to a deep renovation network platform at national scale. We had a second round of national workshops and an EU workshop, which mostly welcomed these draft proposals and tools, but also gave us some suggestions for improvement. For instance, that we need to guide better on when to recommend which action on the EPCs, based on whether renovation is planned anyway, or what is cost effective using incentive programs. And also not only include energy data, but also CO2 emissions and potential CO2 and possibly cost savings on the template. We are currently testing the template in around 100 buildings, including non-residential. And this also confirmed the findings. So discussing, we find that EPCs in their recommendations do have potential for deep energy renovation if they are consistent with deep energy renovation standards, are provided in a user-friendly way, and connected to further energy advice and financial and technical support. It would be better to require building renovation passports, but when will they be improved? EPCs could be the first step towards it. The white paper will update the proposals and concepts, and then we will adapt to national situation and develop further products. Thank you for your attention. Goodbye.
So thank you, Stefan. Thank you very much for this contribution. Since I do not have any question in the chat, I have a couple of questions to you. You raised I think in the second bullet point on the last slide, you compared a bit the improved EPC with the concept of the building renovation passport, and you already worked out a bit that in the end the building renovation passport would maybe the better instrument towards deep renovations and a good consultancy to the building owners towards deep renovation. Maybe you could discuss a little bit why you think that the first step should or could be an improved EPC before this improved EPC could be at the later stage be replaced by a building renovation passport.
One reason is that in the communication on the renovation wave, the European Commission has proposed to introduce a building renovation passport, and maybe in 2023. So we don't know now if the building renovation passport will be introduced at all in all EU member states, and when. Because even if it's decided in 23 at EU level, then it will also take some time to develop. I agree that, and we also write that in the paper, that the building renovation passport is based on a thorough energy advice anyway, whereas the EPCs in some countries, they are only based on the current energy consumption. or they are based on a calculation, but not a very thorough calculation maybe. And because there's also a price issue of the EPCs, and they have the double purpose of not only for the recommendation, but they mainly also serve in the real estate market to demonstrate the current energy performance. And they are only issued at certain occasions. They have to be available for all rented buildings, but not for all others. And the rental market has a different importance in the different EU member states. So of course, there shouldn't be a contradiction between the EPCs and deep energy renovation, and this is what we are working on in our project. And so as long as we only have the EPCs, okay, maybe the number of occasions for which an EPC will be needed will also be extended. So it would be good to improve these in the first step, but yeah, then hopefully we'll also get the building renovation passports, and so then the target should rather be to have that for all buildings to guide the renovation. And then maybe if probably at least the calculation-based EPCs could then also be issued from the building renovation passport, and also if we have a building logbook in the future, then it's this can be combined in this way.
There's now one question in the Zoom chat, which please can you say a bit more about what you mean by user friendliness of EPCs? Does it mean clarity, accuracy, believability of information from the user's point of view, or something else?
Yeah, as the revised template that we proposed mainly focuses on clarity and understandability, and also on the relevance of the information that is provided on the EPC. So we received feedback, for instance, that this traffic light system for the efficiency of the components in the current state was very intuitive to users. And then also some countries that only have asset calculation-based EPCs, they don't have the current energy consumption. And we found that most people also like to see the current energy consumption, because it's also, yeah, a measure of how the building consumes in real use, although we know there's wide variations of that. So this is what guided us. Of course, the quality of the data that is presented should also be good and could be improved in some countries. Yeah.
Okay, thank you, Stefan. I think we already have to shift to the next presentation, but in the end we might come back. We have 10 minutes in the end for a final discussion. So to all of you who listen to this and watch our session here, if you have further questions to Stefan, then just raise the question, write them in the question and answer tool function in the Woover board, and we might come back to that issue in the end. So the next presentation is provided by Adam Hinch. Adam is Managing Director at the Sustainable Energy Partnerships, a New York-based consultancy. And Adam is talking about driving existing building energy improvement, building codes and performance standards, a tale of two regulatory routes. Adam, you have the floor.
Hello, my name's Adam Hinge, and good day to all of you, and good morning from New York, where I am today. I'm happy to be part of this summer study panel today. though in reality, I have to be honest, and like many of you, I think I would much rather be with all of you in the south of France instead of all of us participating remotely from our Zoom caves in different parts of the world. I know many of you in Europe, and suspect that all of you as well would prefer to be together in person. I hope to see many of you again in 2 years at the summer study, if not sooner. And until then, at least for a few more months, we are dealing with the summer study theme of a new reality with a different sort of interaction, though we all might prefer to be together. So for this paper that I'm presenting today, I first want to recognize my co-author, Fiona Brocklehurst of Ballarat Consulting in Oxford in the UK. Many of you may know Fiona as one of the panel leaders for this year's summer study. Fiona is co-leading panel 4 on monitoring and evaluation, and I've enjoyed working with her together on this paper. As a former panel leader for the American summer study version of this summer study, which is organized by eceee, the American Council for an Energy Efficient Economy, I know the tremendous amount of work is involved in being a panel leader, shepherding all of the different papers through the development and review, and really appreciate the effort of Veit, Jan, Fiona, and all of the other panel leaders for this year's summer study. So thank you all. This paper that I'm going to be presenting reports on some work currently underway commissioned by the Australian Department of Industry, Science, Energy and Resources. And this work is an input toward the IEA Energy in Buildings and Communities Technical Cooperation Project. And that IEA EBC program has a Building Energy Codes Working Group. So this work was commissioned as an input to the Building Energy Codes Working Group from the Australian government. Just as some background, the Building Energy Codes Working Group is co-chaired by David Nemso of the US Department of Energy, along with Michael Dunn of New Zealand, and the operating agent for the working group is Meredith Evans of the US Pacific Northwest National Lab. So with that as some background, I'm going to move into the next slide, which gets into terminology. And I don't expect to read all of this, but one of the things we wanted to do was, given past experience I've had where, while we might all be presenting and receiving this in the English language, we have different definitions of what some key terms mean. And I wanted to make sure that we spelled them out for the purpose of this paper, and then also for the purpose of the bigger report that will follow this that is currently in development. This paper summarizes some work where we have been surveying all of the Building Energy Codes Working Group member economies, and we'll be having a larger version of that report later this year. So building energy codes are regulations, sometimes called energy codes or regulations, intended to impact the energy performance of buildings. And I think technical building systems is something that I've heard more widely used. A very mature type of energy policy in much of the world for buildings, and particularly initially started for new construction, but more and more aimed at existing buildings as well. Building performance standards, or more commonly called in Europe MEPS, or minimum energy performance standards for buildings, are regulations or policies that require building owners to meet some performance benchmark or target. And there's often some staged requirements that will increase in stringency over time. And these can be applied in many different ways. I'd like to recognize there's one other paper in the summer study going on, unfortunately, at the same time as this particular session on performance standards for buildings in Europe, co-authored or authored by Louise Sunderland of Regulatory Assistance Program, and we can talk about it later. We have references in the paper, but Louise has done some excellent work on performance standards development for Europe. There are other terms also that are defined in the paper that I won't go through now. I'm going to show several tables now that are extracted directly from the paper. Some of these have a lot of words on that I'm not going to try to get into in much detail, but wanted to let you know the kind of information that is included in the paper. This is a summary of some building performance standards in a number of the leading jurisdictions. And when our paper was going through the peer review process, the reviewers suggested that because building performance standards are a newer type of policy, that we include some summary of the requirements and the types of performance requirements that are in place in some of the leading jurisdictions. You'll see more on this in the paper, and then you'll also see several references that have much more detail in the paper as well. But I think, as you see here, they apply to different types of buildings. There's often a size threshold, but not always. And then you can see there are also stage requirements that will take place and change over time, often tied to some sort of energy performance certificate or rating level. But in the case of New York City and also Tokyo, which is described in the paper, it's a maximum greenhouse gas or carbon intensity for the building. Next, what are kind of the basis of the requirements and how do they differ? As I'd said before, energy codes are generally developed for new construction, though then some of those new construction requirements are applied to substantial renovation or alteration projects to existing buildings, whereas performance standards are based on some sort of a threshold of building energy or carbon performance, generally, as I said, with a performance rating or some sort of energy or carbon intensity. The big difference, and part of why there's so much interest in performance standards now, is this trigger for requirement, that a code generally only applies for an existing building when you're doing some sort of significant renovation, refurbishment, or remodeling of an existing building. And often then that renovation needs to be exceeding a certain portion of the building floor area or value. So there aren't as many times when that would be triggered. A performance standard is generally more applied more widely to a wide set of buildings, perhaps on change of ownership or tenancy, but then you need to bring at some point, either by a date or by that change in ownership or tenancy, bring the performance up to some prescribed level that again can change over time. What are some of the main differences? And I think, as I alluded to before, with energy codes, with building renovation as the trigger, only a small percentage, generally any given year, face those types of requirements. So we're only hitting a pretty small fraction of the existing building market in any given economy or jurisdiction, whereas performance standards really get into potentially a much broader set of buildings. So but that comes with issues. A big one of the implementation issues is that with this new type of regulation, many potentially regulated buildings would not be otherwise subject to ongoing maintenance or other building requirements after having met some sort of initial occupancy certificate. So there are some implementation issues involved. Some of the other pieces, and again, we have more detail about this in the paper, in terms of enforcement and compliance, in many cases for a code, the building control officials may not be notified. It may or may not actually, even if the building is kind of by regulation or by law required, in actual implementation or practice, the compliance may not be enforced as directly. One of the pieces that is an issue with performance standards and why sometimes they're phased in with certain building types or building sizes early on is that this can require a lot of new capacity, not only for regulators, but for building rating systems, building rating professionals, as well as the various contractors and building energy trades that are required to make the upgrades that will bring a building up to the performance level. This again, can become a bit of a constraint in terms of capacity development over time, but at the same time, I think as eceee participants, we are generally advocating for much broader activity in building energy and environmental performance improvement. So this is really driving much more and deeper market activity than would be happening in the absence of these types of performance standards. The enabling or financial issues. In terms of the performance standards, there is basically a requirement that a mature rating or certification system be in place and be the basis for performance measurement. Early on, when I started working on some of this, one of my colleagues in Australia who asked, how, basically when you're trying to set up requirements for existing buildings or even rating, what is the test procedure? And as many of you know, there are lots of different ways of expressing building performance, building energy, or environmental performance. So you need some sort of rating system that can be the basis for that performance measurement. Lots of things evolving, and again, in the paper we have a lot more details, particularly in some of the references that we include in the paper. You can learn much more about all of these from some great predecessor papers that are in place. Really, I think when we tried to summarize a lot of what we learned through this process, and again, this is an ongoing project to support the IEA Building Energy Codes Working Group, but I think a few key pieces that we saw are, in terms of benefits, energy codes are widely understood in most of the OECD and even some emerging economy countries, though much more with application to new construction, not necessarily for existing buildings. Code implementation in terms of enforcement is, we find that sometimes energy codes are not the highest priority, that health and life safety issues take a higher priority. Performance standards, I think the main benefit, as I've already said, is there is a way of triggering major energy improvement activity without other construction such as remodeling or renovation being the trigger. And part of this then is it should definitely drive much more significant volume of building energy improvement in the existing building stock. And the other major benefit that we see is this longer term glide path with staged changes and signals about requirements coming several years into the future that can be considered to have a pathway, maybe through some sort of roadmap or other building passport that can allow building owners to do capital planning to get toward longer term improvements and meeting the deeper targets. The one negative, I would say, there's a relatively new policy lever. There are not many mature policies in place. A lot of them are just taking effect now. So there's a ways to go before we will know what the real impacts are. And there can be a relative lack of familiarity by many industry stakeholders. And that kind of came through even through the review of this paper. Our conclusions, again, this is somewhat repeating what I had in the previous table, but energy codes are a very mature regulatory policy in wide use. I will say there's significant variation we've found among different countries and even within countries. And in the full report that's forthcoming, we will also have kind of some more detailed information about the triggers and thresholds that are applied within different states and localities in Australia when there's the same model national code in place. Performance standards, again, somewhat repeating, but it's a newer policy tool without longer-term, widely evaluated experience, but potentially driving much more energy performance improvement in much larger numbers of buildings. These two policy types can be applied differently, or in some of the jurisdictions, they are being applied together to achieve significant savings in the very large substantial existing building stock, and we see a lot of potential for that to improve and increase in the future. Move on to questions now. I will briefly say that most of you probably know that there is currently an open consultation from the European Commission on potential changes to the Energy Performance of Buildings Directive, and there are some specific questions that the Commission staff have asked regarding performance standards, minimum performance standards for existing buildings. I encourage you to read our paper and ideally to submit some comments to the Commission as well. And here is contact information for Fiona and I in case some of you would like to follow up with additional questions. Thank you very much and good wishes for a great summer study.
Adam, thank you very much for this very, very interesting introduction into into the minimum energy performance standards, in particular in elaborating on the difference between the maps and the building codes. I have one question, because you referred to the ongoing European process in revising the building directive. And we all know that the Commission is thinking about integrating maps into the building directive. You talked about potential triggers. You also talked about the question, which building types should be included, maybe in the first stage. Do you have a strong opinion, a strong preference in the triggers, in the type of buildings that should be addressed first?
I guess thanks for the question, Veit, and I think you've hit the right topic. I suspect there are some who are listening to this presentation who are tracking the European Commission consultation process more closely than I am. And I will do one other plug for a paper. Louise Sunderland, as I mentioned during the presentation, Louise of Regulatory Assistance Project is actually presenting specifically on an ambitious framework of maps for buildings for Europe in this same time slot, and it's the last presentation. So while I don't want to encourage jumping, people may want to listen in on Louise, and there may be some interesting discussion. She's the last presentation in this session, the same time slot. To your question about what building types might be most relevant first, I think one of the things we've seen that I think both in the policies that have been developed and our implementation so far is trying to target the worst performers to try to drive some kind of performance improvement from the worst performers. And while there is a lot still evolving, I think that is the right way to start, to not necessarily have a flood of too many buildings covered by a regulation where there isn't capacity from the regulatory structure or from some of the industry stakeholders to meet it. So I think what I'd say is the worst performers, and then perhaps if you're trying to get the biggest carbon impact in the short term, carbon energy impact, maybe the largest buildings where a smaller number of buildings can have some quite significant impact. So I think that's what I would start with. The other one that I think there's lots of interest in, fits with other European directives, is public buildings should have much more of a long-term view, and shouldn't have the capital constraints, particularly with some of the EU funding streams through the green renovation wave that hopefully will allow for more funding there. So hopefully that is at least a tidbit, and I encourage others to read the paper, and you can see what the results have been elsewhere, and some of the resources, again, particularly some of the work that RAP is doing is very relevant right now.
Okay, thank you. There's an additional question. You raised the point that about the additional capacity that would be requirement with regard to rating agencies, companies that perform all the refurbishment measures. There's one question from the audience. Have you thought at all about the need to have occupational standards for the builders, assessors, facility managers, etc.? I worry that too few people are skilled or motivated to do that, what is required, and they have enormous opportunity to ignore energy standards of any kind.
I think that's a great question, and it also fits with one that I see that one of my co-panelists, Alan Meyer, has put in the chat as well about training of code and inspection officials. I think all of us are very interested. We recognize that we need to scale up dramatically both the amount, the renovation rate of buildings, existing buildings, as well as the depth, and that means we need a whole lot more capacity. If we look at the relatively small renovation rate of only 1 or 2% of buildings per year, and many of them not going to very deep renovation, we're talking about the need for designers, architects and engineers, contractors, inspection staff, and a phenomenal, overwhelming amount of training and capacity building. My sense is where we have not had so much luck with some of the existing policies, the energy codes, or even the EPBD activity to date in driving dramatic deep renovation activity. And I think that's where we see strong potential yet to be tested a bit, because the policies are so new with the performance standards, that if you set a legal bar that is more difficult for a large number of buildings with some significant potential penalties, whether it's the inability to release or let a building, or to sell it, or in other cases a significant financial penalty, that is I guess you could say, when you look at carrots and sticks, it's a fairly heavy stick to drive more existing building performance improvement, that then will kind of bring along with it all of the different stakeholders that you're talking about, as well as a need, probably through some sort of other fees, to drive the regulatory, code inspection or building control officials, both with training and, to be quite frank, many more of them as well, who can focus on whether the regulations are being enforced or not.
Thank you very much. So no open questions, maybe in the end again, but let's use the opportunity.
Thank you all.
Yeah, thank you, Adam.
Look forward to hearing any more questions. Bye for now.
And let's shift to the next presentation, which now we go to Portugal. Now we listen to a presentation which is provided by Luis Amado. Luis is working for the Institute for Systems Engineering and Computers at Coimbra. He's a researcher in this institute, and Luis is talking about the question: how far are Portuguese residential buildings from the nearly zero energy building standard? Luis, you have the floor.
Good afternoon, I'm Luis Amado. I will present the paper entitled "How Far Are Portuguese Residential Buildings from NZER?" In this presentation, I will do a brief overview of energy policies and building policies, then present the state of the art of buildings in Portugal, next some funding and support programs, after a case study on energy performance of buildings, and last, the main conclusions of this work. About energy policies at the European level. In 2016, the Portuguese government committed to ensure the neutrality of its emissions by the end of 2050. The Clean Energy Package, a set of legislative actions on the energy performance of buildings, energy efficiency, and renewable energy. The European Green Deal, a set of initiatives aimed to make Europe climate neutral in 2050. At the national level, the Roadmap for Carbon Neutrality 2050, a long-term strategy for carbon neutrality of the Portuguese economy. The National Energy and Climate Plan 2030, and the long-term strategy for the renovation of the buildings. The National Energy and Climate Plan sets the following energy and climate goals for 2030. Reduce greenhouse gases emissions by a minimum of 45%. Reduce primary energy consumption by 35%. Ensure 47% of renewable sources in gross final energy consumption. Ensure 20% of renewable sources in transport sector, and achieve a target of 15% electricity interconnections capacity. The Portuguese long-term strategy for the renovation of the buildings establishes the indicative objectives for the horizon of the decades 2030, 2040, and 2050. The indicative objectives are the following: renovated building area in the proportion of 363 million square meters for 2030, 635 million square meters for 2040, 747 million square meters for 2050. Primary energy savings of 11% for 2030, 27% for 2040, and 34% for 2050, and reduction of the discomfort hours in housing by 26% for 2040, 44% for 2040, and 56% for 2050. Concerning the building policies, the PBD directive requires member states to establish minimum requirements for the energy performance of newly constructed buildings and existing buildings undergoing major renovations. The Portuguese Decree Law number 118, 2013 ensured the transposition of the EPBD recast, approved the energy certification system of buildings, the regulation of energy performance of residential buildings, and the regulation of energy performance of buildings for commerce and services. In 2018, the PBD recast was amended by the Directive 2018-844, and it became mandatory that all new buildings and major renovations from January 1st, 2021 be NZEBs. Portugal is still preparing some changes in the legislation, expected from June 2021. To be an NZEB, according to the Ordinance number 98, 2019, a residential building must meet the following requirements. The value of the nominal annual needs of useful energy for heating shall be less than or equal to 75% of its maximum value. The nominal value of the primary energy needs shall be less than or equal to 50% of the maximum reference value, ensuring an energy class A. And renewable energy sources shall ensure at least 50% of the annual primary energy needs. Regarding the state-of-the-art of buildings in Portugal, the building sector is responsible for about 30% of energy consumption in Portugal. In 2019, about 5.97 million existing housing units contributed to energy consumption and to the greenhouse gas emissions. Since the implementation of the energy certification system, around 1.4 million energy certificates have been issued, of which around 1.2 million energy certificates are for residential buildings. Of those, 30.8% correspond to buildings classified as at least efficient, classes B- to A+, and 69.2% correspond to buildings classified as not very efficient, classes C to F. The largest contribution to the number of NZEBs in Portugal comes from new buildings, represented in the left top figure, and from major renovations, represented in the left bottom figure. For existing buildings, the scenario is completely different. About 97.3% of the certified buildings are not NZEB. Using an Excel function, a forecast of major renovations up to 2050, represented in orange, was obtained based on the real data registered until 2020, represented in blue. Although the forecast is positive, analyzing the forecast data on a cumulative basis, it shows only a total of 0.29 million major renovations by 2050. This is an extremely low number of renovations compared to the indicative targets proposed in the long-term strategy for the renovation of the buildings. About funding and support programs. The plan to promote efficiency in the consumption of energy aims to promote measures to improve efficiency in electricity consumption. According to the evaluation criteria of the measures of PPEC 2017 and 2018 edition, the residential segment presented higher values for the cost-benefit ratio in all aspects of evaluation, from the point of view of the plan, the consumer, and social, revealing that the energy efficiency measures implemented in the residential sector are extremely beneficial to the electricity sector, to the consumer, and to the environment. Despite that, only around 3 million euros of the total available budget of 23 million euros was allocated to the residential segment. The program in support of more sustainable buildings aims to finance measures that promote rehabilitation, decarbonization, energy efficiency, water efficiency, and circular economy in buildings, aiming occupied residential buildings built prior to 2006. In its first edition, this program allocated 4.5 million euros, with a co-funding rate of 70%, but with a maximum limit per measure on which the co-funding will be made. This is a very good example of a program directed only to residential buildings, allowing to support measures that aim for improving the opaque envelope, in the glazed envelope, in the active systems, renewable energy production, water efficiency, and interventions that promote the incorporation of biomaterials. The Recovery and Resilience Plan is a national application and the Portugal 2030 strategy and is based on three structuring dimensions: resilience, climate transition, and digital transition. Based on the climate transition theme, 620 million euros of investments are planned to promote energy efficiency in buildings. These investments will be divided into 300 million euros in energy efficiency in residential buildings, 250 million euros in energy efficiency in central public administration buildings, and 70 million euros in energy efficiency in service buildings. The Recovery and Resilience Plan should leverage the implementation of the long-term strategy for the renovation of the buildings in Portugal. Moving to the case study on energy performance of buildings. The case study compares a dwelling built before 1990 with a dwelling built after 2013 in different climate zones. These are two of the reference buildings in Portugal defined according the EPBD request and Delegated Regulation 244. With the data collected, we performed dynamic thermal simulation using Energy Plus software to obtain the energy needs in kilowatt-hour per square meter per year for the reference buildings in the 7 climate zones. The table on the right shows the potential of energy savings when comparing an existing building constructed in an era before the existence of legislation, with a new building constructed nowadays, meeting the minimum requirements imposed by legislation. This energy savings was obtained only with measures improving the building envelope, thermal insulation on walls, roofs and floor, and with new windows. This work allowed to conclude that the Portuguese housing stock is too old and was mostly built prior to the emergence of legislation on thermal requirements, so the potential for improvement is huge. Encouraging in a large scale the energy certification of the buildings in Portugal would allow a deep knowledge of the real situation of the building sector. This would contribute to an adequate formulation of energy policies to support the deep renovation of the existing building stock. In Portugal, during the years, energy policies neglected energy efficiency measures that act directly on the passive behavior of buildings. The simulation results make evident the potential energy savings that can be obtained through the implementation of measures at the building envelope level, comparing a building constructed in an era before the existence of legislation with a building constructed today, meeting the minimum requirements imposed by legislation. In Portugal, there are about 157,000 handsets, corresponding to about 2.63% of the housing stock. The amount of handsets was achieved with the contribution of new buildings, major refurbishments, and some existing buildings. For Portugal to meet the objectives proposed in the long-term strategy for the renovation of the buildings, effective measures targeting the existing buildings are needed. This can only be obtained with more and substantial incentives, policies, and also more focused ones. I reached the end of my presentation. Thank you very much for your attention.
Luis, thank you very much for this contribution and your presentation. I have a question. I think you worked out quite well that the majority of the buildings is not NZIP at all in Portugal. So I think that's quite similar to many European member states, and that more efforts are needed to increase this number significantly. From my understanding, what I learned from your presentation is that the main answer so far from the Portuguese government is financial support programs. So my question is, do you think that financial support plus, because you also suggested to improve the information by better EPCs, for instance, do you think that financial support plus better information alone is sufficient? Or do you see that maybe combining financial support plus maybe also some more regulations, like for instance minimum energy performance standards, as Adam has proposed, introduced them in his presentation, could be a way to increase the number of the NZIPs in Portugal?
Okay, thanks for the question. So about the funding, Portugal is one of the countries with the highest level of energy poverty in Europe. So a study conducted for the electrical company concludes that almost 70% of buildings not thermally insulated. According to the same study, 22.5% of the Portuguese population says they cannot afford to heat their homes in the winter and keep them cool in the summer. Therefore, if part of the population cannot afford to heat their homes, how can they afford to renovate them? This represents a major barrier to the renovation of national buildings. A large part of the population cannot afford to renovate buildings. About the legislation for new buildings and major renovations, we are okay. We need to, our new buildings and major renovations needs to be NZEP, so okay, no problem there. But about the renovations, we still don't know how they will occur in the next years. If it's only a measure per building, for instance, or if a building that goes for a renovation needs to be a major renovation, so a combined set of measures. We don't know right now how will be the renovation process. I hope I answered that question.
So I have to unmute myself. There's another question in the chat from Alan. Can you imagine a strategy that combines deep retrofits with some other high priority social strategy? For example, providing greater services to the aging population, converting to electric vehicles.
Yes, it's possible. We talked about the buildings because the buildings can contribute to GHG reduction, emissions reduction, to the main goals of the European policies, the targets. But it's also important the electrical vehicles, for instance, to reduce the fossil fuels, which also contributes to the GHG emissions, the reduction.
Okay. Yeah, thank you, Luis. Thank you very much for your contribution. And now we need, because we are running out of time a little bit, we need to go to our final presentation. Our final presentation is on saving energy in unoccupied buildings. It's provided by Alan Meyer. Alan is a scientist at the Lawrence Berkeley National Laboratory, so another speaker from the US. And Alan, you have the floor.
Hello, my name is Alan Meyer, and I will be speaking about saving energy in unoccupied buildings. Specifically, I will be speaking about saving electricity in briefly unoccupied buildings. I would like to first thank my co-authors, Kurt Kornbluth, Sadia Gul, and Josh Moorjohn for their work in this presentation. Intuitively, we would expect that electricity use in buildings would increase with the number of people inside it, sort of like this graph. Similarly, electricity use should decline as the number of occupants falls. Of course, electricity use will never fall to zero because of necessary safety, health, and security requirements. The reality, however, is very different and looks qualitatively like this orange wedge. The gap between the ideal relationship and reality represents potential energy savings. Now, in this presentation, I'm going to focus on the extreme situation, that is when nobody is in the building. In other words, the building is vacant. This may be for an hour, a week, a month, or even a pandemic. You might ask, what is responsible for this high electricity consumption when nobody is in the building? We have conducted many audits, and here is a partial list. This is a challenging list of equipment because their energy consumptions range from large to tiny. There is also no entirely satisfactory name for them. We use the term MELS, miscellaneous electrical loads, because it seems to accurately capture the whole universe of intended products. But mostly because this acronym, MELS, sounds pleasant to the ear. Standby power use is one component of MELS energy use, but many of these devices are actually operating in their normal modes because they don't know that nobody is present. In the future, it will be much more difficult to think of buildings as either occupied or unoccupied. Instead, we need to treat occupancy more like a continuum. And here are three potential causes for variable occupancy. The pandemic caused enormous changes in building occupancy, but less so in energy consumption. One survey of office buildings, admittedly a special case and a special segment, found that energy use fell on average less than 30%, even though the buildings were mostly empty. A more detailed study of the Empire State Building in New York City, which is an iconic office building, found only a 28% reduction in electricity consumption, even though 95% of the normal occupants were working at home. This electricity use did not include space heating, cooling, or lighting because that was supplied centrally. It was electricity used by the tenants for equipment and appliances. More about that later. Climate change can also cause buildings to become less occupied. One might not ordinarily think of climate change affecting building occupancy, but it has happened in California several times in the past few years, when smoke from nearby wildfires covered the region. The air quality was the worst in the world for at least a week, and our campus was closed during that time. We're pretty certain that new work practices may result in reduced occupancy too. Zoom, Teams, and Skype and other platforms have reduced the need for physical presence in the workplace. Many companies are already reconfiguring their offices in recognition of the projected variable occupancy patterns. Now I will turn to the situation at UC Davis and I think many other buildings. UC Davis knew it had a problem with high electricity consumption in vacant buildings several years before the pandemic. However, the pandemic brought it to front and center. The top figure shows a plot of Wi-Fi connections for the whole campus over time. The Energy Conservation Office tracks Wi-Fi connections to understand occupancy, so we've centralized that data. The orange line is 2019, and the blue line is 2020. You can see how regular and predictable the occupancy is based on the Wi-Fi connections in 2019, and then the consequences of the shutdown of the university and the decline in Wi-Fi connections. In contrast, the change in electricity consumption shown in the bottom graph is almost invisible. That's the difference between the green line and the black line. In the end, occupancy fell over 90%, but electricity use fell only about 15%. That situation was the reason for us to embark on a case study of UC Davis buildings. In the first step, we examined the electricity consumption of different buildings while in normal occupied mode, and then compared it to the lowest consumption recorded. Only one building used less than half of its peak electricity when it was unoccupied. Of course, some of the buildings were laboratories and would be expected to have high continuous electricity consumption caused by the ventilation, refrigeration, and other equipment in those laboratories. From this list, we selected one building for more detailed examination, called Geet Hall. Here's a picture of one building we studied. It consists mostly of lecture halls. I put an arrow to the audio-video rack in the corner because we'll discuss that soon. These audio-video racks are present in every lecture hall and classroom on campus. Here's the Wi-Fi and electricity data for Geet Hall for the period covering a spring break. To be sure, electricity use does fluctuate with occupancy, but energy use, that is electricity use, is still high during the periods when nobody is there. Even more surprising were the causes of the electricity use in the unoccupied building. The audio-video equipment was responsible for about a third. The network equipment room followed closely behind. Now, keep in mind that nobody was in the building using either the audio-video equipment or the networks. This discovery prompted a closer study of audio-video equipment energy use at UC Davis. We employed several techniques to find which devices were hot or energized. In some cases, we had to use an infrared camera to identify the highest consuming components because the campus IT department would not let us switch them off or unplug them. But the IT department also helped us measure electricity use of some racks. One of the unexpected findings was that the newer racks used much more electricity than older racks, both on and off. For example, the Gen 1 unit drew 100 watts in operation and 60 watts in idle. The new models, the Gen 4B, for example, drew 680 watts while operating and 615 watts while in idle. The latest audio-video racks provide many new and valuable services. However, improved energy efficiency is not one of them. These investigations led us to develop a new energy conservation strategy, namely, focus on the extreme case of zero occupancy. We think that strategy makes sense for campus buildings and probably many other buildings because, first, we can substantially cut back on the level of services. That is, no hot water, no chilled drinking water, some electronics switched off, etc. Second, nobody's in the building to complain. That's an important issue. And third, a vacant situation persists for many hours in a typical year. So the potential savings, the potential for significant annual savings is large. You might be skeptical about the opportunities for saving energy when nobody is in the building. Here's a partial list of the measures we are considering. This is a diverse list, but that's the nature of miscellaneous loads and why it's so hard to develop a strategy to reduce them. The middle column describes the modifications that we envision are needed to adhere or to achieve those savings. In practice, we are creating a new vacancy mode. It's kind of like a sleep mode, but informed by external knowledge. That's different from common sleep modes that are simply based on elapsed time since last activity. It also includes many devices not presently having a sleep mode, such as uncontrolled ventilation fans and circulation pumps. Note the large savings fraction. That's because we can be much more aggressive in lowering or even switching off those services during the vacant periods. Now, after explaining the target and potential savings, I want to describe the technical approach. Zero occupancy is a unique condition from both a sensing perspective and in terms of energy savings potential. We can't tap the potential savings unless we are absolutely confident that the building is empty. This requires 3 innovations to shift equipment into that vacancy mode described earlier. First, we need a means of inferring vacancy. The problem is that while we have occupancy sensors, there's no such thing as a vacancy sensor. Instead, we need to infer vacancy from a group of sensors. This inference must be expressed in terms of a confidence or probability instead of the certainty of most occupancy sensors. A vacancy inference engine needs to continuously compute the probability of vacancy from the stream of sensors, schedules, and other sources. The second innovation is a vacancy signal that can be broadcast throughout the building. Actually, it's a vacancy confidence signal or a vacancy confidence level rather than a simple yes/no. Finally, the devices need to be modified to respond to the vacancy probability. I described the vacancy modes for some devices earlier. However, they also need logic to respond to a designated probability threshold value. The selected probability depends on several characteristics. One characteristic will be the device's latency. That is, its ability to quickly recover to normal service levels when somebody appears. Many electronics, such as digital wall displays, have short latency and can therefore switch to a vacancy mode even when there's only a relatively low confidence in the vacancy. This graphic explains the sequence of operations and role of the three innovations. I don't have enough time to describe the logic inside the vacancy inference engine. Basically, it applies sensor fusion methods to Wi-Fi connections, schedules, motion sensors, security systems, and other sources. It needs to be robust and able to accommodate data gaps and easily accept new inputs. Our research is working on all three fronts. For example, Sadia Gul is developing that vacancy inference engine. Josh Moorjohn, who is in the UC Davis Facilities Department, is centralizing the collection of the sensor information. And my team at Lawrence Berkeley Lab is working on vacancy modes for appliances. This is the end of my talk. You don't need to understand the vacancy inference engine, sensor fusion, and vacancy modes. Instead, I hope that you will remember these points. First, vacant buildings are an untapped source of energy savings. Second, the category of miscellaneous energy loads, MELs, is responsible for more and more electricity use in buildings. Finally, we need to develop techniques that enable buildings to become more occupancy responsive, and to do that in an automated way that saves energy. Thank you very much.
Helen, thank you very much for your talk. I learned a lot, in particular that the energy saving potentials in unoccupied buildings seems to be huge. My question would be, how would you translate your technical concepts and your technical ideas into policy? So would you like to see that integrated into a building code for new buildings, or would you like to include that somehow into an eco-design process, so appliance-oriented policy? And how would you deal with existing buildings?
Those are all very easy questions to ask and difficult questions to answer. I'll start with the equipment side of it first, because we can imagine a way in which a program such as Energy Star can include and create, in fact, a new kind of vacancy mode that, in order to be eligible for an Energy Star certification, each device must have a vacancy mode. So that's a voluntary program that can begin fairly quickly. And the advantage of what we were describing is that this whole procedure could be introduced incrementally. It does not require an entire ecosystem to start working. We can bring in just a few devices. We don't even necessarily need a complete communication system. But in general, we need a building code that recognizes that buildings will now need to be more vacancy or occupancy responsive in the systems, and provide the necessary infrastructure to inform all the equipment when nobody or fewer people are in the building. And so that can start relatively quickly But the first step will, of course, be to create the technical standards that will permit us to simplify the procedure for building designers and code inspectors and policymakers. You're on mute.
Yes, sorry. Still after 1 year, the same mistake. Oh, there are two questions in the chat from the audience. Is it possible? So one question, Alan, is it possible that the vacancy interference could be assessed reasonably well with only 1 or 2 variables, Wi-Fi connections, VC, also restroom movement sensors?
Yes, we've already discovered that the Wi-Fi connection is a very good inference of vacancy. However, it's not enough. We discovered that in the buildings that we inspected, there were people outside the building who were borrowing the Wi-Fi signal. And so as a result, did not confused the vacancy inference. On the other hand, there are people who will enter buildings for one reason or another and don't have a mobile phone or something that creates that signal. And you just cannot afford to make mistakes because, for example, we would like to switch off a lift, and you don't want to switch off a lift if somebody is in the building. So you really need to draw upon as many sources of information as possible. And that's, like I said, the challenge of creating an inference that is a probability or a likelihood of occupancy, and make sure that you're pushing towards 99.9% confident when you start switching off some of those important services.
Okay. And there's another question. Alan, would vacancy modes be a target for MAPS regulations? And how many % of the potential savings would the sensors consume?
So the first question is, would the vacancy mode be part of MEPS? Yes, it could. The first step, of course, is one step before that, which is to create a test procedure that knows how to incorporate and test the quality of a vacancy mode. If we have that, then we can introduce MEPS into the, we can introduce the vacancy mode into MEPS. The second question is, how much energy would this kind of vacancy mode itself, or the sensors for vacancy mode, require? For the most part, in the building itself, we hope to draw upon existing sources of information, and that is to say, existing sensors. So the incremental power consumption of the sensor network to gather information about vacancy should be modest. On the other hand, these devices also need to have a sensor to receive a signal. And so then we need to be concerned about the kind of what we would call a radio that can receive that the vacancy signal. If that, with given some of the new technologies, it will be very, very small. And so I'm less worried about that than I was, for example, a few years ago. So if you want exact numbers, we're talking milliwatts or less per device.
Okay. So there's 1 minute left and 1 question left. So connected with the, please, very short answer. What about moving to a skeleton service mode? E.g., instead of turning off all the lifts and elevators, you leave one in operation. Would that work?
I suppose, but if one of the features of the variable occupancy that we can imagine in the future is that it's not fully predictable, and so it will be less certain that a schedule will be able to capture all of these energy savings.
Okay, thank you very much, Alan. So Unfortunately, the session is over already now. Unfortunately, we didn't find the time really to have a panel discussion, but we had 4 very, very interesting presentations, very valuable input. So thanks to all the panelists for providing their presentations, for keeping the time, the 15 minutes for the presentation, for answering all the questions. Thanks to you. Thanks to all the attendees, all the visitors joining our panel, our session. And panel 7 will continue tomorrow morning at 10:30. And I would like to see all of you tomorrow again. So have a nice afternoon and goodbye.